Good morning, ladies and gentlemen. My name is Pavel Kovář. I am from Department of Radio Engineering of the Faculty of Electrical Engineering from the group of the satellite navigation. We are involved with the satellite navigation, with the satellite communication, and also with the signal processing. We cooperate on several projects, like a CREATE project with the Institute of Nuclear Physics of the Czech Academy of Sciences. We also designed the digital spectrometer from the Astronomical Institute of the Academy of Sciences. And I am personally also the amateur designer of the satellites. So I am one of the two designers who developed and operated the Lucky 7 satellite. This spring we will celebrate 3 years on the orbit. Let me say that the satellite is fully functional, and we have data from these satellites. We have heritage with the navigation, GPS navigation of this satellite in the orbit, and we have provided these our receivers to other teams like us. We are open to cooperation. And we learned that for interpretation of the physical data, the precise position and the precise time is essential. So today I will speak about our dream, which is the positioning of the small CubeSat reaching the moon. Let me remember that the return to the moon and the exploration of the Mars is the next plans of the cosmonautics and astronautics. So I will present our method, how we can navigate the small CubeSat in the moon distance using the present GNSS systems. So there are several technical difficulties, which is the very weak signal, but on the other hand, there is up to 100 GNSS satellites, but these satellites were designed for navigation on the Earth's surface. So there are several difficulties which is done by the distance. So here you can see a list of the constellation that is currently available. We have GPS, GLONASS, Galileo, Beidou satellites, and also satellite-based augmentation system satellites that can be used for the navigation. The problem of the navigation is the radiation pattern of the antennas, because the navigation satellites provides the signal to the ground, and outside the signal is attenuated because it is transmitted by the side lobes of the antennas. The other problem is the huge distance that causes the huge free space loss attenuation. So here you can see a calculation of this attenuation and the signal-to-noise ratio of the signal provided by the main lobe and the side lobe. The signal from the main lobe has a relatively high signal-to-noise ratio, but the signal from the side lobe is attenuated of up to 20 dBs. Here you can see the graph for the calculation of the tracking error as a function of the signal-to-noise ratio, which is essential for the most common modulations that are used in the satellite navigation. So the other problem in the navigation on this huge distance is the geometry of the navigation task. That this geometry is described by the DOP coefficients, is the dilution of precision coefficients. I will not go through the details, but we have developed the new methods how to improve the precision of the navigation, and this navigation is possible in such distance even for very small satellite, which is very simple, which is equipped only with the repeater of the signal. So I will compare three position, velocity, and time calculation methods. The first one is the method that is typical or standard for the satellite navigation. The second method assumes the precise synchronization of the receiver clock. It's the fiction because the realization is very questionable due to the relativistic effects. And the last one is the retransmission of the signal from the satellite to the ground station and processing the signal at the ground station. So our idea is displayed here. So we have the satellite near the moon that receives the current GNSS satellites and retransmit the signal back to the ground station for further processing. For investigation of such navigation tasks, we have developed a lunar mission simulator that simulates the position of the all GNSS satellites and also the position of the moon, calculates the satellite visibility, whether the signal is received via the main or side lobes, etc. And we generated several or many graphs. Here you can see the visibility of the signal with the ground station of the different combination of the navigation satellites. If the visibility, if the signal, if the number of satellites is 0, so the ground station is not visible. So here it's for the visibility for the main lobe. So main lobe is good, but the number of satellites is not enough. We have calculated the empirical cumulative function of the outage of the navigation service. We start here. It's this one was for the navigation with the main lobe signals only. Here is for the signal that are received from the main and side lobes. I will go to the results. So here you can the comparison of these three methods. The first method is the standard method, and you can see that the mainly the vertical dilution of precision that measures the errors of in the distance of the satellite is very high, so it's practically unusable. The second method is that assumes that the clock of the receiver is synchronized is much better, but the problem is the the synchronization of this clock on the board of the satellite. And the last one is the proposed method, which is nearly the same as the case of the known clock, but the hardware on the satellite is very simple. So let me conclude our research. The method based on the retransmission of the signal from the research satellite to the ground is very accurate. The main signal processing runs on the ground, so in the ground we can use very powerful hardware for signal processing, so we can process even a very weak signal. And little big problem is the necessity of the visibility of the ground station. So that's all from my speech, and here you can see a space photo from our satellite from Lucky 7. Thank you for your attention.
Thank you. Can we ask for a question? So maybe I ask, do you plan another satellite?
It depends. It's very expensive and it's a lot of work, maybe.
But you have already the experience.
Yes, we have experience.
Okay.
Thank you.
Thank you.